My name is Ethan Bryn, and this is going to be a brief presentation on central processing units, or CPUs. How far has it come, and where will CPUs go next in terms of an evolution? The first step towards modern computers really started with vacuum tube computers that were developed during World War II. They were used in military efforts such as code breaking. When German communications were intercepted, the encryption would need to be broken, and these computers assisted in that effort. You can see a photo here that shows examples of vacuum tubes that were used in electronic devices. And a vacuum tube consisted generally of a glass vessel that contained a heating element that was surrounded by a cathode that was itself surrounded by the anode. And once heat was applied to the cathode in that vacuum environment of the tube, electrons would flow from the cathode to the anode. And it was really this part of the computer that was the original binary component of a computer, where it was charged or on, and that was your 1. It was not charged or off, and that was your 0. These, you can see in this photograph, these vacuum tubes could be larger than the light bulb that you would put in your lamp today. So they were not small devices. They eventually shrunk over time and did become smaller, but they were initially fairly large devices. So vacuum tubes gave way to transistors, which are semiconductor devices that are used to switch or amplify electrical signals or power. You can see in the photograph some examples of transistors. Well, transistors had several advantages over vacuum tubes. They were smaller in size. They required less power. You didn't have a heating element in transistors like you did with the vacuum tubes. They were more reliable. You didn't have a seal to fail the vacuum. They had a longer service life. You reduced the size of the computer because the size of the transistor. You reduced the initial cost, and you also reduced operational costs. You weren't constantly replacing vacuum tubes any longer now with transistors, because they had that longer, more reliable life cycle. So then you had transistors becoming part of integrated circuits, and it was the integrated circuit contained the transistor as well as other components. And this happened in the early 1960s. Then in the late 60s, integrated circuits were themselves integrated into microprocessors. And microprocessors have evolved in part to what are current day central processing units. And some of these processing units have as many as 24 cores, like the Intel Core Ultra 9 processor 285K, or 16 cores like the AMD Ryzen 9 9950X. And the Ryzen 9 advertises their multi-threading capability, so handling 32 threads. The Core 9 only advertises 24 cores. I saw no indication of hyper-threading within that processor. So what comes next? Where do we go from here? Well, we started with our single core CPUs way back when, Intel Pentium processors. Now we're up to 24 cores with the Intel that's supposed to be released late this year, 2024, or the 16-core Ryzen 9 from AMD. Well, you also have specialized processors that allow CPUs to offload some of their tasks to these subordinate processors and share the workload that can help speed up some of these processes and allow the CPU to focus on the bigger picture of the computer's task. You also have new materials that are being researched and looked at to improve efficiency, reduce heat, and these will increase the life expectancy and reduce energy consumption. Heat is the enemy of the computer and the processing unit. That's why they shut down if they get too hot. Well, if you don't have as much heat to deal with, the processor itself will last longer. You don't need as much energy. And you think about data centers and server rooms that require dedicated cooling units to deal with the heat generated by all these computers that are within those centers. Well, that's a tangential cost to this, but it's directly related. You reduce the heat, you can reduce your operational costs. So in that effort, you have some of these, you are looking at graphene with its increased cooling abilities. You also have carbon nanotubes that are being looked at that can potentially be used to create transistors even further reduced in size, but with an increased switching speed and lower power usage. Of course, with the smaller size, you have an increased number of transistors that can be put in the same physical chip size. More transistors, more processes can be handled. You also have the potential use of artificial intelligence coupled with current CPUs that can allow for more efficient and predictive use of those CPU resources. And I think all three of those are very viable options for the short-term evolution of CPUs. Again, significant increase in the number of cores, your different materials to increase efficiency and reduce heat, as well as using AI and machine learning to better use CPU resources. Then you have entities like the University of Minnesota who are conducting research in other architectures and what they call spintronic devices. And these are based on the up or down spin of electrons instead of electrical charges or current. Then you have things like quantum computing. And this is a much longer term evolution due to technological constraints and challenges that must be overcome to make them a more everyday type of device. But quantum computers can perform calculations exponentially faster than classical computers. For example, a recent article published talked about Google scientists with a 70 qubit quantum computer that they said was 241 million times more powerful than a classical computer. And it finished a task that they calculated would have taken a classical computer 47 years to complete. And this quantum computer did it much faster. But of course, with most new technologies, this will likely be very expensive for quite some time. So again, I think our short-term evolution is going to be AI and machine learning, more cores, and new materials. And that's where our CPUs will be going next. Well, thank you for your time, and have a great day.